Hey there. All right, so today we're going to look at polynomials, kind of all things polynomials, pretty much just the basic stuff here. Hopefully this will be pretty quick and easy for us. The first thing, though, I want to talk about is classifying polynomials because there's a lot of vocabulary that we use that sometimes, you've heard and the teacher says, but you don't really connect what it means. And so when I use terms, I need you to know what I'm talking about. And so there's two ways that we will classify polynomials. One of them will be by its degree, and that means its power. So what is the highest power on a particular term or on a polynomial? So in this first one, I'm just going to go down the list here and I'm just going to fill in the boxes on what we would classify this as. So this first one is just a 7. There's not even a variable involved. If there were going to be a variable, it would be an x to the 0 power, because anything to the 0 power is 1 and it would just go away. So it's not really there. We don't see it, but we need to recognize that that is a 0 degree. If you have a 0 degree, then that is always going to be a constant. Okay, so another scenario. Now, I've given you kind of some weird ones. These are a little trickier than maybe previous courses. This first one, you can see there's some like terms that I should be combining. So when you're doing this, though, regardless of whether there's like terms or not, you're going through each term individually and looking at what its degree is, and then you pick whichever one is the highest degree as the degree of the polynomial. So here's a constant. I know that's a degree 0. But this one is a degree 1 because this is an x to the first. Here's another x to the first. So the highest degree that I see is a first degree. So we might write that as a first degree. But we actually have a name for that. Anything that is a first degree is considered to be a linear term. All right, on this next example, you can see the degree on this term is a 1, the degree on this term is a 2, and this term is a 0. So the highest degree on any particular term is a 2. So this would be considered a second degree. Anything that is a second degree is called a quadratic. Now that's one that we use a lot, and I feel like it seems weird because doesn't that prefix quad imply 4 to you? It does to me, but it's not. It is a second degree. All right, look at the next one. What do you think the highest degree is? Okay, it would be a third degree. All right, if you have something that is a third degree, we call that a cubic. I think of that cubic as sort of like it's three-dimensional. When you get a cube, it's three-dimensional, so it's a third degree. All right, now the next one is a little bit weird because I have different variables in it. So when you look at this x is to the first and this y is to the first. So together that would be a second degree term. This is a fourth degree with a fifth degree. So that is actually, I'm sorry, a fourth degree with an eighth degree, which is actually a 12th degree. This one has an x to the first and a y to the third. So that'd be a fourth degree. So the highest degree that I see is a 12th degree. Now, believe it or not, we don't have a name for that. At some point, we kind of cut it off. And so this would just be considered a 12th degree. We don't have a fancy name. So typically, I kind of have the list. It goes, here's a constant, linear, quadratic, cubic. We use quartic for 4, quintic for 5. And after that, we pretty much just call it a 6th degree, 7th degree, 8th degree, whatever. Okay, the other way that we will classify polynomials is by how many terms are in it. So looking at this first one, you can see that's just the 7. There's only one term there. So that would be considered, okay, if you only have one term, then that is considered a monomial. Mono meaning 1. Okay, so looking at those prefixes. Now this next one can be sneaky because it looks like there's 3 terms, but remember that these 2 terms were like terms. They actually would combine, and that's why I gave us a little bit of extra space. This would actually combine to a 5 plus 3x. And so it's really only two terms. The prefix for two would be bi. So two terms would be, oops, let me change that. Two terms is a binomial. All right, next one has three terms. That's a trinomial. And then the next one has four terms, and we don't really have a name beyond trinomial that we use. We use mono, bi, tri, and then we just go to poly. Poly means many, and it's sort of a generic term. Oops. And so it can be many, but it's a generic term, and each of these is like a subset of a polynomial. I can call anything a polynomial, but then I can break it down more specifically to a monomial, binomial, trinomial, and so forth. Okay, last one has three terms, so I would go back to a trinomial on that one. Okay, so being familiar with some terminology, so it just comes natural when I say it, you know, you can envision exactly what it is I'm talking about. Now I'm going to try to incorporate those words as we keep moving through here. I'm going to look at adding, subtracting, and multiplying polynomials. So adding polynomials and subtracting, you have to combine like terms. So I have a trinomial. This is a cubic trinomial. This is a cubic polynomial. I'm going to add like terms together. So by like terms, I mean the variable parts have to be identical. So I have a 5x cubed, and over here is assumed to be a 1x cubed. So that is a 6x cubed. You always want to start with your higher power and work your way down. Then I have a negative 7x squared that can combine with this 2x squared. So that's a negative 5x squared. And then I have a negative x that does not have a like term. And I have a plus 8 with a negative 3, so that's a plus 5. So my end result is a cubic polynomial. All right, the next one is just the same thing as the first, except that we are subtracting. And it's important to understand this subtraction here is subtracting all of these terms, not just the first one. I'm a big fan of changing this to adding the opposite, because sometimes by the time we get way down to the end, we have forgotten to distribute that negative sign all the way through. So that's what I would do. Then I'm back to combining like terms. I got a 2x cubed, I have a negative x squared, and now I have some like terms. I have a negative 1x with this positive 2x, and then I end up with a plus 6. So another cubic polynomial as an end result. Now, when we multiply, the scenario you're probably most familiar with is this, what we call FOIL. But FOIL is really just distributing. It just happens that when you take a binomial times another binomial, as you are distributing, it kind of uses this acronym of FOIL. Because what I do is I take this 2x and I distribute it through this the second polynomial, or the second binomial. And then I take this negative 4 and I distribute it through. And by doing that, I distribute, so I take the first times the first, then I take this outer times this outer. Then I go here, inner times inner. And then last times last. And that's where that FOIL comes, that acronym comes from, just from knowing that. Now, this is about, I'm not going to lie, you did this in Algebra 1. So this is not rocket science. Really, at this age, at this stage, I should say, what you should be doing is a lot more mental math. That's kind of the expectation by now, that you can multiply the first together. 2x times x is a 2x squared. And then you should also recognize, and have done this enough times, that the outer and the inner are going to be like terms that will combine together. So we should be able to do that in our head. We have a 10x and a negative 4x, so we should write plus 6x and just do that in our head. And last is going to get you a negative 20. So quadratic trinomial there. I know that some of you are like, oh, but can't I just write this as two separate terms and then take another step? Yes, you can, but I'm going to tell you, if you're not using some of these shortcuts, you're going to fall behind pretty quickly. You have to force yourself to step up your game a little bit. So now here we have a scenario of a trinomial times a trinomial. On this scenario, you are distributing. We don't have a cute acronym to go with it, but it's that same process. Now, some of you are going to be really awesome and impress me with your mental math skills. Do you know how many terms you're going to end up with on this one? Okay, so you should recognize that, well, there's going to be 9 terms because I'm going to take this one times all 3 of those, this one times all 3, and this one times all 3. I'm going to have 9 terms. But I also should recognize that there's going to be some like terms that will combine. Now, if you're really showing off, you might even be able to recognize, and this isn't always the case, but these are kind of your standard. You've got the second degree, first degree constant, second degree, first degree constant. If it's generic like that, your first term is going to be an x to the 4th, and then you're going to end up with an x to the 3rd, an x squared, an x, and a constant. So really, you're going to end up with 5 terms out of that. A 4th degree all the way down to a 0 degree is 5 terms. Now, if you knew that, I'm super impressed. I'm not going to expect you to have to be able to do all of that in your head, but if you're doing a binomial times a binomial, yeah, I'm going to expect that. So very quickly, I'm going to run through this. Actually, I'm not. I'm going to have you pause the video and do this one on your own, and then come back to me after you've done it on your own. Then you come back and see if you and I agree. But pause the video while you do it. Holy smokes, did you expect that to happen? I didn't. All right, lots of stuff that canceled out on that. So my end result, I lied earlier. This is not going to end up with 5 terms because so much stuff canceled out on it. So really what I end up with is a quartic binomial as my end result. Okay, so now let's go back to this binomial times a binomial. There are certain situations that are special, and we should start being familiar and recognizing them when they're in front of us. So this is a scenario where, yeah, I could do FOIL on this, but these are special binomials. They are what we call conjugates. They are identical except for the sign. Now, conjugates are very handy, and we use them throughout algebra. Let me show you what's special about them here. If you were to go through and do your FOIL, you'd have your 5x times 5x. You would do your outer and your inner, and then your last. And this right here is what's special about multiplying conjugates together. Your outer and inner are always identical except exact opposites, which means they will always cancel out. So your end result comes out to just a 25x squared minus 81. Okay, so that's handy to recognize, both going this direction, but also backing up and getting back into that stage. So both of those scenarios are worth noting how that plays out. Okay, now here's another special situation, but different than earlier. These are not multiplying conjugates. If you were to really look at this would be a 6x minus 5 times itself. Notice the sign is going to be the same on this, which means your outer and inner are not going to cancel. Now, again, I'm expecting to kind of step up your game here. Probably your teacher had you write this out twice and then FOIL it together, which is good, because here's what we really, really, really do not want you to do. You do not get to take this squared and distribute it. Distributing is a multiplication game, not a power game. So you can't just distribute a power. because distributing is a multiplication process. So let's look at how this really plays out. And so again, we've got to step up our game to hang on to this. Otherwise, we're going to fly past you. So looking at this scenario, you take and if I were to FOIL this out like you have done in the past, you would have a 36x, sorry, I'm going to go back to my blue. 36x squared. Outer is a negative 30x. Inner is also a negative 30x. And then you end up with a plus 25. So my end result is 36x squared, negative 60x, and plus 25. So now what our goal here is to be able to get from here to here without all this extra work. So looking at this, what I'm trying to do is figure out the shortcut to that. Where does it look like your 36x squared would have come from? Up here. Well, that's just 6x squared. So that temptation to distribute a power and get a 36x squared, yes, that is there. Even the temptation to square this, yep, that's here too. But what you get is this middle term that if you're just distributing, you lose this middle term. So then the trick is figure out where is this middle term coming from? Well, really, that's just you multiplying these two together. There's your negative 30x, but you're going to always end up with it there twice. So what we do is we multiply these two together, and then we double it because we know it's always going to be there twice. So no more of this. I'm going to expect you to go to this stage. So looking at this, could you do this example right here? This little guy here in your notes always means I want you to try this one by yourself without me doing it with you. So that means you're always going to pause the video, you're going to go work through it, and then you're going to come back when it's done. So try this one using our new shortcut, not your old way of doing it. Okay, pause the video. Okay, so here's my answer. Here's again how you do this. Square the first term, got it. Multiply the two, and then double it. And then square your last term, and you've got it. Now, as you're squaring that last term, it maybe is worth noting that this is always going to be a plus sign, even up here when this was a minus, because when you multiply these, since they're always going to be the same sign, you're always going to have a positive there. This sign will always match whatever that sign is. Okay, hope you're learning something new on these and doing them also. Okay, here's my next level. We did addition, subtraction, multiplication. Now we're going to do division. Now, division can be pretty straightforward, can also get a little bit trickier. So let's start with something I would say is a little bit more straightforward. If I'm going to take a polynomial and I'm going to divide it by a monomial, ultimately what this is it is taking this trinomial that I have listed here, and it's taking the entire thing divided by this, which means every single term has to get divided. So what that would look like, if you were to take and do a step of work with that, you would take your 16a to the 5th, and you would divide it by a 4a cubed. And then you'd have a minus sign, and you would do 12a to the 4th over 4a cubed plus 8a squared over 4a cubed. And you would look at each one of those terms and divide by that 4a cubed. Now, I feel like this gets thrown at you a little bit early because we haven't yet refreshed your memory on exponent rules. That's coming up. But I think the assumption is you've done exponent rules like this at least since Algebra 1. So again, you should recognize an a to the 5th divided by an a cubed is going to get you an a to the 2nd. You just subtract these exponents. So you're going to divide here and then subtract your exponents. So this is going to get you a 4a squared minus, the next term is going to be a 3a plus, the last term is going to be a 2 oh, this is weird. Notice that they did not just decrease, and this isn't like a cubic. If this was a cubic, then these would have canceled, and my answer is just 2. But what's different here is that I have more A's on the bottom than I do on the top. So if I were to be canceling these out, again, we're a little bit ahead of the game on this. I haven't reviewed this with you, but if you had an A times an A, that's your A squared, over an A times an A times an A, well, these would reduce, and you have an extra A on the bottom. So my last term is actually going to be 2 over A. And that's what my final answer will look like. I'm not going to try to do anything else with that. Now, some of you would maybe like to do that exponent rule where you'd write 2 minus the 3, so you'd write a to the negative 1. Well, you can do that, but you should always simplify that. Anything with a negative exponent gets shifted, and that a ends up down in the denominator. So this, what I boxed in, should be what your final answer is. Now, do you need to go through all of this work? Well, I'd like to say no. No, you don't. But the question is, do you need to? So if you can just in your head envision, I'm going to divide here, I'm going to divide here, and I'm going to divide here. I would love that. I would love for you to get from this stage to this stage without all of that work. That would be great, as long as you're getting the answer correct. Okay, let's try this next one. It's a little bit harder. Look at all of this stuff going on. I've got way bigger numbers. I have 2 variables. They're much higher powers. You've got to know those power rules on your variables. I'm going to let you try this one on your own. I might suggest this until you get a little bit better at this process. But if you're super smart, feel like I've got this, and I promise I'm going to get it right, then I'm going to let you just go straight to your answer. You do what you need to do to get the answer correct. All right, this one's on you, so pause the video and come back when you have your answer. All right, here's what I've got for an answer. Take a moment, look through that, make sure you agree. If not, go look and see where you might have gone wrong and how I got my answer. Otherwise, we're going to keep moving. Now, when I said that the division could be easier and then it could get more complex, here's an example where it's going to get a little bit more complex on us. I am no longer dividing by a monomial. I now have a binomial here. When we have a binomial, then what we use is long division. And there are different ways of doing this, but long division is the one that we're going to practice here. And so when you do long division, it looks like this. This is called your divisor. The denominator is your divisor. There's a little 4th grade for you, huh? Inside here, anybody remember what it's called on the inside? That is your dividend. Maybe not 4th grade. Maybe 4th grade. Okay, not 4th grade, 5th grade. Okay, so what I'm going to do is I'm going to divide this binomial into this polynomial. And to do that, you kind of ignore this piece right here, and you're just looking at this leading term. And you're saying to yourself, 2m times what would get me a 4m cubed? Well, I'd have to take 2 times 2, and m would need to get multiplied by m squared to end up with an m cubed. So what I do is I put 2m squared there. Now, I should have made a note here, also something, and we're not going to get too tricky until a few chapters down the road, but if I had any missing terms, like if this squared term wasn't here and it was just this, this, and this, I would have to put a 0 m squared as a placeholder to keep this column, because I might need a column for m squareds. But I didn't make anything fancy here. Okay, so once you do this, Now you take this 2m squared and you multiply it by your binomial and place it under here. So this is just like you would do with numbers. So 2m squared times 2m is 4m cubed. That's what I wanted to have happen. But then I also have to take that 2m squared times the negative 1. So that's going to be minus 2m squared. And then if you'll recall from long division, after that, you subtract. Now, this is worth noting. It in your notes, perhaps use a red pen, a highlighter, something, because I am going to subtract, but what I do to subtract is ultimately change the signs. So this minus is going to turn into a plus. And if you just do it in your pencil, you kind of lose track of why is that a plus? That's supposed to be a minus. But what we do is we change all the signs. That's going to make this cancel out. And then I have a negative 12m squared and a positive 2m, which is then going to get me a negative 10m squared. Bring down the next number. Okay, now we start all over. 2m times what gets us negative 10m squared? Well, this would have to be a negative 5m. Now I'm going to take my negative 5m and distribute it through that binomial. So negative 5m times the 2m minus 1, and I put it here. So that's going to get me a negative 10m squared and a plus 5m. And then I'm going to change the signs to show the subtraction. So that's going to go to plus, that's going to go to a minus. These are going to cancel. And then I'm going to have a 10m. Oops, I still want that to be blue, trying to keep this neat and organized. 10m. Bring down the next number. Okay, so now what I'm going to do is I'm going to say 2m times what gets me 10m? That'd be a 5. Just take 2m times 5. So in that sense, it's a positive 5. I have to put a plus here, plus 5. And then distribute, so that's 10m minus 5. Change the signs. The 10m's cancel. And I get an 11. Okay, so once your value here has a lower power on the variable than what's here, that means you're done. And in a perfect world, not only would have the 10m's canceled, but the 6 would have canceled, and this would have come out perfectly. That means that it divides nicely, and you would have a remainder of 0, but I don't. I have a remainder of 11. So since I have a remainder of 11, I'm going to, what you could do, like in the 5th grade, probably, you would have written remainder 11 and called it good. But then you got smarter in the 6th grade, and we learned that really what you do is you take your remainder and you put it over your divisor. And since the 11 is positive, I write plus 11 over 2m minus 1. And then this is my answer. Okay, this is not your dividend. This is not your divisor. This is your quotient. That is the answer when you do division. It's called the quotient. All right, now that one, I'm not going to do a bunch of these. I'm trying to, most of this should be review for you, but if that's iffy, maybe go back and rewrite or watch that video again. That's a little bit higher level for sure than the other stuff we were doing. All right, so I said I wasn't going to do another one, but I do want you to try one. I've amped it up a little bit. Look at what I did to you. We've got some missing terms in here. Do you see how the X term is missing? Over here, you have an X term that's missing. So you kind of have to watch out for that. I'm going to get you started, and then, looky, this is on your own. All right, I'm going to get you started so you don't just start right off with something messed up. But when you set this up, you're going to put your X squared. Leave space up here. Remember, your quotient's going to be up there, so don't write up there too high. So I'm going to have an x squared plus 0x minus 4. And then I'm going to have a 3x cubed minus 2x squared plus 0x minus 150. All right, now this one's on your own. See what you can do with it. Come back when you think you have your answer, and we'll check each other. Pause the video now. All right, here's what I've got. If you disagree, take a minute, look and see where you can find your error, and then let's keep moving. Got one more slide. One of the things that we're going to do in college algebra is probably do some more application. You learned a lot of skills in Algebra 1 and Algebra 2, and now in college algebra, we're kind of using those skills for some real situations. So when you're dealing with polynomials, this is one of those things like, where would I ever use this? Okay, well, here's an example. And this is actually leading into a calculus type of problem. It's not to that level, but this is something that you address in calculus. So it's the volume of a box. Now, my box is what we call an open-topped box, because you can see there is no lid on this box. And from geometry, you might have learned like the net of this. Like if you were to try to build this box out of a piece of cardboard, and you'd have a flat piece of cardboard, here's how you would make it. You'd cut corners out of this, and then each one of these are little tabs that would fold up, and it would create this box right here. Okay, so for that to work out, how much this tab flips up has got to be the same as how much this is, so that they line up nicely on this corner. So you can see I have designated that as an X measurement. Now, the original piece of cardboard I had was 12 by 20. I don't know. I guess it's in inches. It didn't really say there. I don't know why I didn't put units on that. But so what we're doing is we're looking for what is the volume of this box. And of course, I'm looking to see the volume of a rectangular prism is what that would end up being. And from geometry, the volume of a rectangular prism is just the length times the width times the height. Okay, so let's look and see what that would be. I'm talking about the length, the width, and the height of this. Not really this, but now I'm looking at the box. So let's call like this is your length, this is your width, and this is your height. So the length here is not really the full 20. The length is really like this measurement. So it's not the 20, it's the 20 minus the two chunks that you cut out. That's what this would be. So this measurement right here is your length, and then this would really be the width. And it kind of creates the base of that box. So length, I would call 20 minus 2x. What do you think your width would have to be? It'd be 12 minus 2x, because you're subtracting x on both ends. Now, what do you think the height of your box is? Well, it's this measurement right here is just how big of a square you cut out right there. So if this were to flip up, then the height of your box is just x. Now, we could distribute this all together, but there's no need to for what we are doing right here. I'm just going to leave this as my formula. So now what I'm going to check here is, can you determine, ultimately kind of what we're looking at is, does the volume of the box change as we change the x value, or does the volume ultimately stay the same? Because as this x gets smaller and smaller, this box is going to be like a really shallow box. But the base is going to get bigger and bigger if you do that. Now, If you make x really big, then it's going to be really tall, but as you force this to get bigger, then your base is going to end up getting smaller. Doesn't matter for your volume. Okay, well, let's check. Let's evaluate the volume if you let this be a 3 by 3 square that you cut out. So ultimately, you're letting x equal 3. What would the volume be? Okay, so what I'm going to do is I'm going to come over here. I'm going to do my volume would equal, it'd be 20 minus, and then I'm doing this for the sake of your notes. I figure a lot of this you could just do in your head. Sorry, I'm going to do minus 2 times 3, which I know is just 6. And then I'm going to do 12 minus 2 times 3. And then I'm going to take it times 3. So 20 minus 6 is 14. 12 minus 6 is 6 times 3. That multiplies together to get me 252 units cubed for my volume. All right, so let's check. Do I get the same volume if I make x be 6? So this is going to be a really tall box with a small base. All right, I'm going to let you try x equals 6 on your own, see what the volume is. Go ahead and pause the video. All right, so this is what I got. I got a volume of 0. Is that what you got? Okay, so number 1, nope, they're not going to have the same volume. And number 2, nope, you're not wrong if you got 0. It really is 0. Does that make sense to you? Let's go back and look at the picture up here of the net of this. Think about this for a minute. If you let this x measurement right here be 6, well, this whole length of your cardboard is 12. So if you come in 6 this way and come in 6 this way, do you see how those would actually just be touching? And when you were to flip this up, it would just be a flat piece of cardboard again that would have a volume of 0. So that's why it is 0. It's okay. That's what you're, so you do have some limitations. And to be honest, that has to do with your domain. What can you allow x to equal in this function? Well, if I'm trying to build a box, I can't let x be 6 or any bigger than 6, because the bigger it would get, the more issues I would have. So when we talk about domain and why do we care about domain, well, here'd be an example. We'd have to have that awareness of what we're allowed to let x equal for this to really work. Okay, that's all we've got on polynomials today. Hope this helps.